Hello, I am Dr. G and I'm glad to meet you today at my channel. Probably you already know what we will do today. Indeed, we will do the following simplification. We need to simplify this expression. The specific feature of this expression is existence of modulus of x plus 2 in denominator. We will start immediately, and first what we will do is we introduce this function just for convenience. Next, I would like to outline the solution. First, we will analyze the modulus itself. Then we will write the function without modulus. Next, we find domain of our function. And the last step is we will write function in simplified form in its domain. I would like to draw your attention to this part, find domain of fx. Because a lot of students ignore this part when solving such problems. Let's start with analysis of the modulus. We recollect definition of modulus. It is here. Please take into account that here is greater or equal, so 0 is included in a range of possible values of a. We use this definition to write x plus 2 in this way, or we will little simplify this. It will look like this. So here we distribute minus, and here we write these inequalities in this form. Then we represent the results in graphical form. We see that the number line is divided in two intervals. One includes -2 and all numbers to the right, and the second doesn't include -2, it includes all numbers smaller than -2. So our analysis we will split in two parts. One we will call case 1 for this part of the number line, and the second case is to the left hand side of this line. So we start with x greater or equal -2. In this case, modulus of x plus 2 equal this. We can see the numerator of our function, factor x, and then we represent this quadratic polynomial as a product of two linear terms. Please check yourself that this expression is correct. You should know how to do this. Then we go to denominator, which has this form. Again, we use modulus in this form. Rewrite, distribute x, it will be this one, and then we see that we can cancel x squared, and what remains is 2x plus 4. We factor 2, and this is the denominator. At this point, we can write function f of x for the case x greater equal -2. We will not cancel x plus 2 at this moment, because this term can be equal to 0 at point x equal -2. For this reason, we need first to find domain of fx for the case 1. What is domain? Function is here. It doesn't exist if denominator equal to 0, so denominator should be not equal to 0. So domain is defined by inequality x not equal -2, or we can write that x should be greater than -2. Then we rewrite fx in its domain for case 1. So we take this expression here. Now we know that x plus 2 not equal 0 because we are in the domain of function f of x, and we can cancel, and what remains is actually the simplified expression for f of x in this interval. Next, we go to the case 2, x smaller than -2. Here we know numerator already. Then we take modulus of x plus 2 and rewrite the denominator as follows. Just follow my calculations. If you have questions, just leave a comment and I will reply later. So here we have x times this, distribute x, rewrite in this form, factor -2, and this is the same polynomial which we had before, so we can write as a product of x minus 1 times x plus 2. This is denominator of our function. Plug in function, and we have the following expression for function fx. Now we need to consider domain of fx for this case. For x smaller than -2, x minus 1 is always not equal to 0. X plus 2 for x smaller than -2 is also not equal to 0. And what we have now, that domain is this interval itself. Function in this domain is equal to this expression. This multiplier is not equal to 0, so we can cancel them. And we have the answer for our function in this domain. Actually, this is simplified expression for our initial expression in this interval. We can write final answer in this form. So for x greater than -2, we have this expression. For x smaller than -2, we have this expression. Please, I draw your attention, x equal -2 is absent here, because it is not included in the domain. Let's return to this point. Let's suppose we didn't consider domain, then our answer will have a wrong form. Here will be x greater or equal -2, and why it is not correct. Let's consider first part, because the second part remains the same for both cases. This expression doesn't exist at x equal -2 because denominator is equal to 0. It's easy to check. At the same time, the right-hand side exists at x equal -2, and it is equal just 3. So this is not right to write here equal. There is no identity between left-hand side and right-hand side parts. So this answer is incorrect at x equal -2. You may say that this is a minor issue, it doesn't affect the answer, and you will not be right. In math, if you make such kind of mistake, anyway, your answer is incorrect. So be careful with the domain of function when you try to simplify more or less complicated expressions. And now, at the end, I would like to encourage you to write your answer as a comment, and I will reply later. If you like this video, you may want to click like icon, leave a comment, general comment, and subscribe for the channel. I will be happy to see you next week. We will consider some other problems. Have a good time.